into this little area because the camera, so I'm going to just try to not run around. All right, so welcome everybody. Thank you for coming. I misspelled Python. I apologize about that. How many of you guys really want to see this in Python? How many of you guys would really love to see this in Link and C#? All right, it's decided. So we're going to do this in .NET, and what's really awesome, like this is one of the things that is awesome about MongoDB, is it doesn't really matter what language you're using. There's support for like the most archaic language in really nice ways. Do you do Haskell? There's like an awesome way to program MongoDB in Haskell. One of the best, literally in my opinion, one of the best ways to talk to MongoDB is C#, right? And the reason is the link integration is like a thing of beauty, right? So you'll see that MongoDB has a different type of query language. It's not SQL. It's sort of this prototypical JavaScript, JSON, object type thing that we'll talk about briefly. But of course, when you use a link statement against it, it will translate to that underlying language, just like it would for Entity Framework to SQL. Okay? So let me just ask you guys quickly, how many of you are using some form of NoSQL database? All right, many possible converts, beautiful. So I've done a lot of work with SQL Server and a little bit less with things like SQLite and MySQL. And this is more fun. This is easier to work with, easier to maintain, and faster, and it's free. So there's a lot of reasons in those things to sort of pay attention. All right, so we're going to look at a host of different things. We're going to quickly just talk about like what is this NoSQL stuff and why do I care. And then we're going to see, I'll sort of talk you through installing it. We're going to create an app from scratch, create a database, and write some code and do some queries with Link. And then we'll talk a little bit about some of the really efficient type of operations that you can do. All right, so if you, could somebody shut that door back there? Do you guys mind? Just pull back the stuff. Thanks. Apologize about that. Oh, but maybe hold on 1 second. No, you can't come in. The session's closed. Okay, so here's my view of the world. Like you guys are probably a good statistical sample here. When you sit down to talk with people about building a new application, I think it typically goes like this. We're going to build an application. What type of architecture should we use? Okay, we're going to have our SQL server, and now how do we talk to it? And what do we going to use web services? Are we going to use a message, some sort of like BizTalk type thing? Are we going to do REST? Like there's all these interesting conversations, but they're like, we have this relational database. Now let's talk about how we're going to build our app, right? This stuff has been super successful, but when was the last time people were like, maybe SQL is not something we should use, right? It's just the thinking is I have data, it goes into a database, right? And by that they mean relational database, right? So I think if nothing else, this should sort of give you, some ideas to just think about this. It doesn't mean you should not choose SQL Server. It might be the perfect thing, but think about it. Okay, so why has relational databases stuck around for so long? Well, there's a couple reasons. We already know how to make those work at scale. They're reliable. We are comfortable with them, right? This has been going a long time. Tool support is great. I can go to Visual Studio, go to Server Explorer, connect, boom, there it is. I can go to, pick your IDE or pick your database data management tools. They almost all speak some sort of SQL, right? Think of Redgate tooling and stuff like that. They have ACID properties, which guarantee a lot of things. A lot of people even use the database almost for thread safety in some ways, right, to deal with that. DBAs, they've been doing this forever. And so, that's their world. If you switch away from their world, that's a problem for them. Like I said, concurrency, and not so much these days, but they have been used traditionally as what I'm terming integration databases. So what is that? Well, an integration database looks like this. Here's a bunch of apps. Imagine these are like web services or something. And the way you share your data, you guys looking to take a break? Not so much, huh? Have to close that in a minute. The way you share your data is they all point at the same database. Ta-da, problem solved, we're sharing our data. Well, if you've got like a user account in there, think how complicated that user is, because this app has a slightly different need than that app and that. right? You want to make a change. This is where the DBA group is like, oh, you need to come talk to us, because if you make a change, you're not just going to break this guy. You're going to it has these far-reaching implications, right? However, people are moving away from these to these things called application databases. Now, application databases don't necessarily mean, they rarely mean NoSQL, but they look like this, right? So now we're going through some kind of service layer, that's the installation, right? And then each little app can have its own data that it stores. And this means the way you store your data matters less to the other apps. So you could put like a NoSQL bit here, SQL Server here, maybe some other kind of NoSQL thing there. Right? And long as the service stays the same, who cares? Okay? So that's great. All right, so I'm going to skip ahead just a little bit so we can do some demos. Now, we're using MongoDB because it's really popular and it really works well. But let me give you guys some other motivation here as well. And if you were in my previous talk, you know what the next slide is, but it's okay. So there are many options for these NoSQL databases. I could choose CouchDB. A lot of times people are like, oh, CouchDB, I heard it's so awesome. Why don't you use it? Okay, it could be awesome. We'll see. We can talk about that if you really want. RavenDB, I've heard, is the best one for .NET because it's written in C#, so it must be the best one for .NET. I think there might be more .NET people working Mongo than at Raven, but that's a different question. But if you were going to bet your career on one of these trends, or at least your next step in your career, you might consider where are the jobs, where are the tools, you know, where's the experience, and one of these looks different than the other, right? MongoDB is just by far, this data I think is, this is up to last week data. So we've got Mongo, Couch, Cassandra, Raven, and Rake. And the blue line obviously is MongoDB, right? It's like many, many more times. It's about 100 times more popular than Raven, and I don't know, over 10 times, maybe 15 times more popular than Couch, right? And obviously it's not high school, it's not like a popularity contest, but the reason there are 20 or 30 different languages you can program this database in is because so many people are using it and they're tested. And you know, databases like MongoDB have been through some insane sort of scenarios that some companies are putting them through that, you know, you might not have to, but they'll uncover problems that you might not otherwise have done. All right, so how do we scale traditionally? We scale like this, right? We buy a bigger server. With Mongo, you'll see the way that we build up our data is we can scale horizontally. Talk about in a minute why that is, but that means we can scale for less money with more reliability, right? It's not a single point of failure. You just go buy a bunch of cheap machines in EC2 or put them into your server, data center, things like that. All right, I have a whole other talk which you can watch on video because it's in the past on sharding and replication and stuff like that. It's really pretty amazing what you can do, but we'll sort of leave it at this. So MongoDB is open source, like I just showed you on GitHub. Go to GitHub/MongoDB, and then there's the server and all of the drivers. All of it is open source. It's free, 100% free for commercial use. The way they make money is they sell services on top of this. They sell consulting, and they sell like management tooling and stuff that you can use. But you can go and get the database and do whatever you like with it, right? Okay, so the way you get it is you go to mongodb.org. It's a little tricky. There's mongodb.com that it's actually very hard to find the download from. It's just the company website. You know, somebody should maybe work on that. But anyway, mongodb.org. It's worth looking at as well. If we go over here, hold on. Go back. Why don't you want to go sideways? Ah, dear. I'm going to have to undo this. Which means that's not so bad. Okay, so if you go over here to mongodb.org and you wait for the conference internet, you can see download MongoDB 3.0. And actually, this just was released like a week and a half ago. This is a big deal. They've changed a bunch of stuff, and there's a lot of performance improvements and stability improvements. One notable change is that writes are 10 times faster than they were in the previous version. So that's anything that gets 10 times faster is like worth paying attention to. So you can come down here and download it, and this is pretty interesting. I can get it for Windows, You pick your server, old server, new server, get it for Linux, get it for Mac, right? So this works cross-platform, and it's super easy. It's also worth noting, spelling is interesting, services, okay, a little delay. So if I go down here and say view local services, and I click here and type in, there's MongoDB running just like SQL Server runs, right? So we at Developmentor, where I work, we do all of our hosting of our websites in EC2, and they run on Windows, and they have MongoDB as the backend. And you click this button, auto start, and we haven't had to worry about it for like two years. What we have had to worry about is running out of disk space, but that's a different problem. Okay, so you get it, you download it, it's super easy. You basically unzip it, and there's like a command line thing you type to register it as a Windows service. Off it goes. It takes about, here it would take a little while to download, but it takes, about 30 seconds to set up. If you're really experienced, maybe 5 minutes or 10 minutes to download and set up if you guys are new. It's not like SQL Server where it takes an hour and a half and it reboots 4 times or something like that. You just download it and go. Okay, so let me try this. I think that will be better. Let's do, here we go. I don't think I have any annotations. Should be a little easier to switch back and forth because we're going to do a lot of demos. Okay, so you download it, you install it basically by uncompressing it. They now have an MSI in it. It's okay. You do that as well, and off it goes. All right, so programming. Let's talk about how you work with MongoDB. What you'll see that's different, there's a few mind shifts you guys have to make. One mind shift is, if I go to the server explorer for MongoDB, there's not a table designer, right? The way that you define the shape of things that go in this database is you put stuff into the database, and that's the shape it is. And if you put them in as different shapes, then that table now is sort of a heterogeneous thing. That's not a good idea. I don't recommend this, but it supports it, right? Like your tables should have, basically, they should be consistent. But the database doesn't have a schema. You'll hear people say this is a schema-less database, which is not entirely accurate because any reasonable use of it, there is a schema. It's just not enforced by the database. And the place it's enforced is in your application. So speaking to C#, that means it's enforced. Yes, hold on, we'll fix that in a minute. It's enforced by the shape of your classes. Okay? So your sort of architecture in C#, your data access layer that you write, is more important here than it is in Entity Framework, because it's the only thing that keeps that integrity there. It's not that hard to write. In fact, you should have a good data access layer in Entity Framework. People don't always do it, but you'll see that it's kind of more required here, let's say. Okay? All right, this now requires that. All right, so what we're going to do is we're going to define some C# classes, and in C# these are mapped one-to-one to some, they're not called tables in MongoDB because they're not tabular, they're called collections. So I'll switch back and forth, but collections are mapped basically to C# classes. You can do things like inheritance and other stuff, but same rules as any framework. Like, you probably shouldn't, but you could do it, right? It supports it. The amount of control that you have over how stuff is serialized to and from MongoDB is ridiculous. There's like a crazy amount of options you have there. There's attributes you can put on your classes to control it. There's interfaces you can implement. There's tons of various options, okay? All right, so let's just go write some code, and then we'll come back and look at more slides, because I feel like if you guys are new, this might not be the best. Let's say it later. Thanks. There's a lot of stuff interrupting my computer, isn't there? So what we're going to do is we're going to go over here and write some code. Now, here is something that I did only, let's try this totally from scratch. Hopefully this works. The internet may or may not cooperate. Let's browse over here. Just go to the desktop. Make a new folder. Let's call this DevWeek MongoDB Starter, whatever. So I'm going to create a console app. This is an unlikely use case of MongoDB, but it's a simple scenario, right? Obviously, this would be like a web API or ASP.NET MVC or some sort of back-endy thing. All right, so we get a new project. We wait for ReSharper to come into being. And we come over here, and to get started, what I really need to do is I need to add a reference to what in MongoDB parlance is called a driver. Okay, this is like the data access layer, ADO.NET equivalent. So what I need to do is go over here and say manage NuGet packages. You guys all know NuGet, yes? NuGet is amazing. So we're going to come over here and type MongoDB, and you wait. Now there's the official .NET driver from MongoDB. Right now it's on version 110. They're about to release a new version that's more sort of takes advantage of things that are in the new server, but also adds async and await support. Right, so if you guys know about like the async and await stuff in C#5, that's coming really quickly here. And you can see that there are more than 5 pages of things here. You can just keep going, right? So there's like ASP.NET session state providers and all kinds of stuff that you might care about. But the one you really care about for what we're doing is this one. Now, it's easy enough to get started with this, but there's a little bit of work that you have to do. So instead, if you type Kennedy up here and you search, there's this thing called the optimistic concurrency from MongoDB, which adds the same type of concurrency support that Entity Framework has into MongoDB. We don't actually care about that right now, but it has some nice classes you can use. And as part of that, it installs the thing I just showed you. Okay. And it says, okay, what you want to do is you want to get started by creating a class that looks like this. All right. If you guys want to talk about the concurrency stuff, we totally can. But just the important thing is notice we have 3 references now. MongoDB.C#, MongoDB.bson, and driver. And then we have this other one that we just added that I probably could have named better, but that's what it's named. So we're going to start by having I'll just put this in a folder. This probably should be in a separate assembly here. So I'll call this data. Right? So down in this data layer, let's add a class called MongoDB Contacts or something like that. And the idea is that this class needs to derive from, let me write this out longhand first. Notice there's a concurrent data context that enforces this concurrency model that Entity Framework uses, but there's also this basic one that's simpler. So we're going to use that. Now you can see ReSharper gives it like red squiggles. And let's see why. It says you must implement an interface. All right, well, it looks like we're going to have to pass it some stuff here to pass down to the base. And we don't really care about overriding this stuff. So let's just do it like so. All right. So we're going to need to pass the database name, and maybe in this application we already know what the database name is. So we would say something like just hard-coded here. All right. Hard-coding it might not be exactly what you're doing. Maybe this is in like a web config or an app config. But for this is going to be DevWeek demo 2015 or something like that. All right, so now what I need to do is I need to have some classes. How many of you guys are familiar with Entity Framework Code First? I don't know for sure, but my theory is, okay, a few of you, my theory is Entity Framework Code First is largely motivated by the experience people were having with Mongo and Raven and some of these other things. They're like, oh, why can't we just create classes and have data? Let's see if we can do that. It kind of goes like that. In Entity Framework Code First, you derive from a class, and then you have these properties, which are Queryable of the thing. Let's create a bookstore, let's say, right? Let's stick with a blog, because I already have a bookstore that I might want to show you later. So one thing we might have is we might have posts. No, I take it back. We're doing a bookstore. So we'll have books, let's say, in here. And so we need the class book. Right, so MongoDB or Entity Framework Code First is you would create a class that is the thing that represents the way you want to store your data, and then you just start talking to your database. So what we need to do is come over here and say, I want a class called book, and what do you guys think a book has? What?
Author title.
Title, absolutely. We're gonna have, that was awesome. Sorry, wrong hotkey. Too much Mac. It's bad for the Windows. Okay, author. Now, would author be an object or would author be a string? This is interesting. Let's stick with the string for a moment, but yes, let's keep going here. Oh my gosh. Okay, we're going to add, maybe it has, maybe it has multiple authors. Right? This is not uncommon that a book has multiple authors. So, I'll have to fix this once and for all. Okay. So, maybe it has multiple authors. How do I set up that relationship? What if I just say this is the list of string? Now, if this were, and I would pluralize this, make it plural. So if this were in the framework code first, I could also write that. But what that would do is generate a separate table in a foreign key relationship. That doesn't mean that in MongoDB, as we'll see. So let's leave it like this. And let's just say that it's actually going to have an author class. It's going to be, it's probably not the way we want to keep this, but just so I can sort of demonstrate this in the simple version first, let's have a class called author. And this author is going to have a string name, and what else does an author have? Let's say the author has a byte array photo or something like that, right? That's kind of something like that. I don't know. So this is the data related with this person here. So we can actually put these objects inside of one another. And let's go over here and add one more thing. Let's add an int page count. Okay. Now, because this is going to be stored in the database, it needs a primary key. Title is probably not the best primary key. And in MongoDB, I could use a string as a title, but there's something that's like a GUID that is the default auto-generated sort of thing. So what we're going to have is we're going to have something called an object ID. We'll call that ID. Okay, cool. So this is not doing it for me yet. We're going to need to do something different here. So when we say this, we need to say, go to the base and get the collection of this type. And what does this return? This returns an iQueryable of the type. Right? This is one of the reasons that you add my little library so you don't have to worry about what that means. Right? So we go to the database and we grab this and it returns something iQueryable. What's special about iQueryable? Why do I care about this in terms of data access? This is the gateway to awesome right here, you guys. If I do a link statement or expression against an iQueryable, what happens when I run it? Usually.
Lazy.
It's lazy and it actually gets translated to the underlying native query syntax. If this was IEnumerable, it would just cram through it in memory. But because it's iQueryable, it talks to the underlying driver. The driver is the MongoDB driver, and it says, oh, you say where, order by, take. What that means is da-da-da in MongoDB. And poof, off it goes. All right? So basically, at this point, you can forget that you're doing MongoDB. All right? It's no different than Entity Framework or other sort of stuff that you're familiar with, except for that it continues to be awesome after you create the database. Okay, so let's go over here and let's add a little method that says create some data, and we'll create it like so. And down here, we're going to say, all right, what we're going to do is create a contact. We'll say new MongoDB Contacts, Mongo. I must remember what I called it. DB Contacts. There we go. Like that. And cannot access protected thing. That is not the best. Let's go here. Oh, Mongo Contacts. Sorry. DB Contacts. It was the underlying one, which is like an abstract type. Perfect. Okay, so we're going to create this, and we'll create a book. Equals some book here. That's almost what I wanted. And what are we going to do to it? We'll say it's got authors. Let's for a minute leave authors alone. ID is going to be auto-generated by the database. Page count, this is going to be a good book. It's got 200 pages. And the title is going to be getting started with MongoDB, or something like that, like so. Let's do one little quick thing before we save this. When I create this object, well, let me just suppose I'm going to try to add some authors. Let's say book.authors.add. This is not a MongoDB thing. This is a C# thing. So say this is going to be a new author, and they have a name. Name equals Ted. Another one's going to be Bill. All right. So we're going to put these two authors in there. Now if I run this, it's going to be suboptimal in that there might be a problem. It's not a data problem, remember. What is this problem? Obviously something is null, as you can see. What is null?
Authors list.
Authors list, yeah, and this is a complete pain. So this is how you fix this. You go over here and you say constructor with this.authors equals new thing, okay? And you just initialize it in the constructor. That will happen even when you get it back from the database, but then it goes, actually, we'll just stuff this data into it, right? So now if I run it, it's more awesome than it was. It actually works. But there's still no data because I haven't saved it. How do you save stuff in Entity Framework? You guys remember? You do an add, that's true, but then you say save changes, right? So like an add plus save changes. MongoDB is kind of slightly different. You say save, and then you give it the item. So it doesn't do identity tracking in the same way, but you also can skip the add, so it's in some ways less work. Now, this might be a little awesome. First of all, let me show you some really cool tools. There's this thing called RoboMongo, which already, who wouldn't want to use RoboMongo? But this is cool because it works. It's this app, and it works the same on OS X, Windows, and Linux, right? So just like the server's cross-platform, so is the DB, the management tools. Also open source, also on GitHub, also free. So if I go over here and we look really carefully, there's cool stuff like develop.com, that's pretty awesome. But there is no database involving DevWeek, yeah? If I run this, and I refresh this, there's now one called DevWeek. Okay? You can open up, and there's only one collection called books, and I can look in there, and I can see what there is, and there's this thing, which I can kind of go like this and look at it. You see it as these authors, and that's the data we added, yeah? Except there's other views as well. There's the native sort of view. This is how MongoDB stores this. So you guys are familiar with this concept of the object relational impedance mismatch, right? Which means I've got like 20 tables that I'm doing some insane join on, and then out pops an object, and I work with it. Oh, it's a perfect object, and then I save it, and I'm going to tear it back into those pieces. And most of the time it's good until you need to understand about those relationships, because I want to delete one thing, the cascading delete is not set up right or whatever, right? There is no object relational impedance mismatch in MongoDB. The shape of what I had in memory is the shape of what goes in the database. I reach in, pull it back out, put it back in, right? So you can't have cycles, basically, but as long as you don't have cycles, you can put things in here. And these can be small, like they could be 1 or 2 little columns, if you will, or they could be quite large. They could be like 16 megabytes is the current limit. Apparently stuff is happening in Dropbox, sorry. So this is really cool. Now, the question becomes that people who are sort of still in the, it's not me this time. It's the question becomes, how do you query it? Right? It's cool that you can put it in there in the shape, but surely this is a problem. Right? This is cool, but it has to be a problem. There's no way this is going to be okay. What is one of the few pieces that is really magical that makes this work is it's still okay. I can still go to my database and ask the question, show me all the books that Bill wrote. And I can do that in like a ridiculous amount of speed. All right, so let's go over here and look at this for just a moment to give you an example that has more than one record. Because if I show you one record comes back fast, you'll be possibly unimpressed. You might be impressed still, but you shouldn't be super impressed. So this is something I talked about in my previous performance talk. There's this bookstore data that some guy is like put together. I don't know what his motivation for this was. He was like some kind of researcher, and he like mined a ton of data out of Amazon.com, and he got 270,000 books and 1.2 million reviews about those books, and he built a CSV table out of these, and I took that and imported it into MongoDB for playing with it. So let's look at what we got in this database, which has more. If I ask, by the way, this is the query syntax of MongoDB, what you see me right up here. The other thing that's fantastic about this RoboMongo thing is you basically type queries in native syntax up here, and what comes out is stuff that you can like UI work with, right? So you have all the power. Like there's nothing you can't do in MongoDB via RoboMongo, but you have a GUI for that, which is, by the way, a unique thing in the MongoDB world. So I can ask how many of these are there. There's 271,000, and within these, oh, and you get IntelliSense, which is pretty awesome. DB dot. Right, okay. So if I go over here and I look, you can see that there are ratings about these. Let's go down in the middle somewhere. You can see this thing has some stuff, and it has ratings, and there's different users that have rated it. And this guy rated it a 0, hated it, loved it, it's okay, right? And here you can see their primary IDs. And this is like a foreign key type of thing within MongoDB to them. It's not enforced in the database, but it's something like I've referred to as like a weak foreign key constraint. The foreign relationship is there, but it's got to be enforced in code, which is, we can talk about that. But maybe I want to find all the books that this person reviewed. Okay? So what that means is basically some kind of join where I go, let's think in relational database terms for a minute. I go to the book table, and I go to the author table. Well, technically, if I grab the ID, I'm just going to like the book to review table. And there's a review over here, and then over here is the books. And I want to do that join on those three things and get this back, right? So you would do it like a two-way join or something like that in relational databases. Here, you're like, this thing is stuck way down in there. How am I going to even query this? One. And then two, if I do, is it going to be super slow or not, right? So let me just copy this value and go up to the top and ask this question. So the way that you do queries in the native syntax is you give it like a JavaScript JSON object that usually matches on some field. So I would say something like this. I'm looking for the ratings piece, and inside there I'm looking for the user ID. So I would say ratings.user ID is this value. But there's also greater than, less than. It's in this set. Like most of the SQL operators you know exist. They just have like a little funny like operator symbol at the front of their JSON name. Okay. So remember, 271,000 books, 1.2 million reviews of those books. It's nested inside them. Those of you who were not at my talk yesterday, what do you think this is going to take to answer this question? How long? Second? You think it'll be faster in a second? Seriously? No way, right? No way. So it took 8 milliseconds. That was slow because the indexes were on disk. Let's try it again. Less than 1 millisecond. Okay? So because you have this shape, like the thing you would always think is, well, there's this shape which breaks querying. It doesn't break it. Think of these as like pre-computed joins. And if you're really going to use these things together a lot, just store them together. If you're going to use them separately, put them into what you would think is separate tables with a relationship. Right? But it does not mean you cannot query them. You can query them really fast. So you can sort of more closely model your objects that you have, but you can still query them. And what's interesting is oftentimes what you'll find put into one of these documents here is the stuff that you use together 80% of the time. So if I do some sort of scale out and I just go and grab one item from one bit of the server, I very likely have everything I need. I don't have to go back and do joins across all the machines and all sorts of stuff. But even so, even if you have one server and you don't have a performance problem, this is super smooth and easy to use. So far we're kind of up to where Entity Framework code first would have worked. You could have shown me the same demo and you said, let's see how cool it is. It took like 30 seconds the first time I ran it, but then it generated a little MDF database over there. And then it kind of calcifies, like the volcano comes down, freezes it solid or whatever, and it's done. It doesn't evolve anymore. And there's this whole complex migrations, upgrading, downgrading stuff that gets super hard. But it turns out in MongoDB, whoops, that is not at all what I'm running. Cool. Wait. These things are still flexible even after you create them. So let's create another. Let's go over here and actually change this. First, let's get some data back. Then I'll change this data for a second. So let's just actually comment out just the invocation. Well, let me create some more data because it's. Let me just hold it. We'll change it, then we'll do something. But let's first query it, and it's going to come up pretty uninteresting because there's one record. Nonetheless, so let's go and say find some data here, like so. And let me create this context. Now, what would you guys write if this was an Entity Framework and you wanted to find all the books that have 200 or more pages? Let me help you. Var books equals. Now what? From B in books, where B dot page count is greater than or equal to 200, order by B dot title descending. Let's go B dot page count descending. So that's easy to think about. Select B. Yeah. That's what you write in MongoDB as well. So you guys already know it. You just didn't know that you know it. So we could write out each one of those books. And if I could even do like a count, a take, a skip, all of that would translate down to deep down. So we say for B in books, var B. Oh my gosh, my Python is showing through. For each thing in books, B print, got the right line, I'm telling you, too much Python lately. Okay, we're just going to have 0 with curly 1 pages. We'll say B dot title, B dot page count. If we run this, MongoDB with 200 pages. Now, granted, there's only one book. It's not super interesting. Now, yesterday the question was, okay, well, this is cool, but what the heck, what just happened over here? Because something happened over here. I could write it out, but you guys would not, it wouldn't mean a lot to you to know how would you write that out, right? So we can do this. Go over here. It's a Team Explorer, just kidding. Come over here to NuGet. And we can search for query helper. So you may find it. There's this one called MongoDB Query Helper. The guy who wrote it is pretty awesome. No, just kidding. So I wrote this. It's on NuGet, on GitHub. You can grab it and do whatever. So we can install this, and I can come down here and I can say, well, let's see. Just query is. I'm going to go books.to Mongo query text. Boom. It's a little hard to see. Hold on. Whoop. Page count. And you can see there's a little greater than operator, the dollar greater than. Now this is a pretty simple query. It could be more complicated, right? So this lets you kind of understand what's happening in Link. And then I could take this, I could go run it in RoboMongo and like debug that or whatever, right? So you don't necessarily have to learn too much about the actual native query syntax to get started, because you just write it in Link and go, well, I need that. Just give me that and I'll put it over here. Yes?
What was the order by statement?
So that to query text only shows the parameter that goes to the find operation, which is it's a good question, because the way you do it is you do in like an order as a separate thing, and the way the driver is currently written, I can only access that parameter. I could do more interesting things. I don't know if it would come through if I do like a take and a skip and so on, but I could do a little more. I could say like b.title.contains TED, I don't know, whatever. So we could run it and you can see it'll like do a little regular expression on there. Or I could do something even more interesting. I could say b.authors.any, b goes, author goes to author.name equals Ted. All right, and I'll run that. And there you get this part and authors element match this sub-item on this set, that subset, right? Yes?
Is there anything like SQL profiling?
Yes. Is there anything like SQL Profiler for the camera? Yes, there is. Let me show you this by way of an example. Where are you hiding? Here. So on that book data set with the 1.2 million rows and so on, I've got this little app that like shows you how to generate the indexes and things like that. So I can just walk you through this a little bit. So if I come down here, let me just see, like here's the enable profiling. So here's what you write. This enables profiling, and this one like resets it, okay? So you go to the MongoDB Contacts, and you go to the database, set profiling level 2, and you have 3 choices. All, log everything that you see happening. Nothing, which is the default, and slow queries. Now, what do you guys think counts as a slow query? What kind of number would you set? Like, this thing is so egregious it must be inspected. A second? Half a second? 100 milliseconds? Like, if it's under 100 milliseconds, is that good enough? So the one we were using here is 5 milliseconds. If it's more than 5 milliseconds, it's a problem and we need to look at it. Okay. Just to tell you, over on our website, we've got a couple that run on Mongo, and there's not a bunch of big data, but like the search stuff and so on. There's like 200,000 records for certain things. There is not a query on this website at develop.com that takes more than 5 milliseconds across the board. So we don't have to worry about caching because, geez, our database is already faster than the cache, right? Or as fast as the cache, and that just simplifies everything, right? Okay, so this is how you turn it on, and then this just lets you turn it off. So let me just run this, and you can see it's going to like remove all the indexes. Wasn't planning on showing this, but since you ask, it removed all the indexes, and then it did some queries, and it said. It had just asked a bunch of typical questions that the app would ask via link. And then it said, and it turned on profiling while it did that, and it said, now tell me the stuff that is slow. And so we could actually go into the database and look at this. But these are the queries, these are the tables, book, user, publisher. And this is the stuff they're doing right here, okay? And then I can say, well, show me the things you were trying to do to answer those questions. So here's actually, it was trying to figure out how many people live in, how many of the users are 18 years old? There's 3,703 of them. And we can ask using that library that I wrote, the 2 Mongo query text, you can ask, tell me about your query plan, if you will, okay? And it said we're using a basic cursor. Basic cursor means no indexes, this is the problem. It took 150 milliseconds. It was already kind of fast. How many people live in Calgary? Apparently a ton of them, I don't know why. Calgary, Canada, 69 milliseconds. That might be okay in like normal database land, but it's not okay in Mongo. So we're going to add back indexes, and then we're going to rerun these questions. And it says, okay, we reran all those same questions. What ones were slower than 5 milliseconds? None of them were. Okay. All right, well, let's ask this question again. 18 years old, 0 milliseconds. How many people live in Canada? 0 milliseconds. How many users are who are this? I think this is wrong. This is like between. I don't know. There's something going on with the like what this is reporting. How many users are in this age range? Took 11 milliseconds. Now it says 11, but it actually, because that was the time it took to stream the data back. Plus the sort of response time is what's measured versus the streaming time. And when you get like 100,000 records, it takes a few seconds or a few milliseconds to get them back. That's why these numbers are a little off. How many books did John Grisham write? Well, he wrote a whole bunch, and it took 0 milliseconds to answer that. Right, so when you get sort of this kind of performance, you no longer need caching and a caching layer and all of this junk that goes in there that makes it super hard to write apps. You just write this code. And this is on a single machine, right? We could scale this out if we had to. All right, so that's the profiler. You can enable it. You basically ask the questions, and then you can go back to the database and see what was happening. Does that help? There's not a UI for it, but It's not really that hard. It's worth asking about, well, how do you actually add the indexes since we're on this? So you just come down and you write code like this. So the one that was super fast for finding the users, how many books this user rated, was because this index was there. I said, I'm going to go to the object, go to its ratings property, which happens to be an array of objects. Within that array of objects, there's a property called user ID. So you write that, and now you have a complex sort of composite index. Does that make sense? Okay, pretty cool. You can do it in LINQ, like this funky, weird way, or you can just throw that in there, and it's good to go. All right, let's see. We could get back and edit our, let me go back to this other thing. We could get back our books and we could edit them. You get them from the database, you make changes, you call save, right? Exactly like Entity Framework, except for you have to pass the object. Let's see, let's go back to the slides for just a minute, unless you guys have questions. Yes, go for it.
What if you wanted to change your name, Bill?
Yeah, okay, fantastic. What if I want to change my name? Or even if I wanted to change the schema, right? Yeah. So that's the good idea. So we're going to create some data. I'm going to query some data. So I could do this. Let's go find our book, which is here. All right, so here's our book. Now, let's review what happens in SQL Server if I make this change, right? Suppose I want another field here, right? For starters, then we'll go and change something more directly, all right? So maybe I care about when this book was published. Date, time, published date, yeah? So this is when it gets to be interesting, this sort of schemaless thing or schema controlled by C#. What happens if I run this in Entity Framework? Cannot, column not found, death to application. What has happened to you? Here, it doesn't matter. It's all good. Okay? It's like, whatever. I couldn't find something to set this. It's cool. What value you guys think date time has, or my published date has? Whatever the zero memory structure of a date time is, it's just not set, right? It's just didn't set it. Now, I can go over here and create more data. Let's go and add another book down here and say, we can come down here and say date time, published date equals date time dot now. So close to good. Because that's not a problem. All right, so Bill, and maybe we're gonna have another author over here. Jeff came along and decided to help out on the revision. Okay, so we're gonna add another one. Let's go over here, and this one actually is more pages. They had it a whole section. It's now 250. So if we go create some more data, also okay. However, there's a bit of a weirdness here, and this is something you guys should think about. So if I go over and look at this again, one of them has no published date, and one of them does. That may or may not bother you, right? Because it still has the C# default value, or whatever value you want to default, set to in the constructor. It would just keep on everything. But if I go to MongoDB and I write a query, say, show me everything published after this date, or maybe better yet, published before this date, and the zero value would think it would fall into that set, would not show up because it translates to LINQ, from LINQ into the query syntax goes to DB, looks for that property, and that property is not on some of them. That's a problem, okay? So here's how we fixed it at Developmentor. Actually, let me show you the proper way, like how we literally do this. We go over here and we say link pad. Isn't there a link pad? Link pad is awesome. It turns out it works with MongoDB. So, all right, so I go over here and I press F4, and I say browse to my thing, my use stuff, which is this. Let's grab it. Okay. And then I come over here and I would say var context, actually, this is statements, equals new Mongo, let's say DevWeek, is that what it's called? What did I name this thing? Oh, it's not public. Sorry, hold on. These all have to be made public for this trick to work. So close. Make it public. Make it public. Compile it. DevWeek. It's pretty awesome already that that happened without me refreshing it. Context, right? So I'll create one of these. I'll say for each var b in ctx.books, ctx.save b. And what that does is it'll basically pull it back up. All the defaults that are set in C# will now like get back set into the database. So if I rerun this, if I run it over here, and then I go back and I refresh this, now this has just like the 0 published date or whatever. But it sort of re-syncs everything, so the way it looks in memory is the way it looks in Mongo. So if we make a change that's significant enough that we might need to query against that property, then we'll do this. Now, remember, what we've had to have done if this was Entity Framework, this would be like, we're going to need to generate an update script. We're going to have to beg the DBA to apply the update script to the QA thing. There's going to be a period. There'll be a nighttime event where somebody applies it to the server. This doesn't happen here. We just go, boom, release. Like, right-click, publish to EC2. It's done, okay? I'll show you the develop.com stuff where we actually have the website kind of revalidate the indexes and stuff, so we don't have to like move those around. It's all automatic. All right, now this is not all unicorns and good stuff. What if I wanted to name this to primary authors? And I actually did the refactor, so my app would still run. It's slightly less happy. Oh, no, it's, am I not querying it? This is unexpected what is happening here. Maybe because I blasted in those books? No. Did they change this? It's used to crash. It should crash. Create data. Hold on. How many books do we get back? I'm getting one back. Primary authors. Oh. There we go. So it says element authors does not match any field that is on the book. Basically what it says is, look, you've got this object in memory, and you tried to say, go to the database and load all the data from that one document into this thing, and it said, but there's this piece that has nowhere to go. So I could do that. I could just go, forget it, we won't put it up there, it's good. But if you call save changes, that little dangling piece is history, right? And you may not be aware that you're going to be wiping away data. You think your app is just fine. You ran the old version. Where'd the data go? I don't know. There was 1 billion records. Well, now they're changed. I'm sorry. So it's like a safety mechanism. So there's two things. This is the one part where what you're asking about gets complicated. Not complicated. It has slight challenges. So I can say things like, you know what? Right now, I want to rename these things. And I could just say I'm trying to erase that field before. And then I could say bson ignore extra elements. It's almost the same thing. Bson ignore extra elements. And now it'll run fine because you're basically saying, I know there's stuff that's going to get thrown away. And when I do that resave, I probably destroyed this somehow. It could be wiping away these things, right? I don't think I resaved them, which is a good thing. But if I would, this would have been gone. And that's maybe what you would do if you wanted to, like, say this field is just history. Now, what if I wanted that field to actually be migrated from the old one to the new one? I would do something different. I would come over here and I would say, you know what? There are now these two things. Just hold on, give me a moment. There's going to be two things, and it's going to look weird. You could write a script in JavaScript that does this. So just so you know, this is not required. So you would say return authors. this.authors. And you just say, if somebody asks for primary authors, give me that data, right? So when the database loads it, it sets this property. When it goes to save it, it says, I see you have this property, what's its value? Oh yeah, it's the same as the other one. If I go over here and I do this, just compile it. If I go over here to my link pad, this is why it didn't run. If I go rerun this, and now I look at this again, we have primary authors and authors, which I may have screwed up. Oh no, here they are. Here's authors and primary authors, right? And so just for that moment, and then I come back over here and go, you know what? Okay, now you're really gone. And this goes back to get a T and a set without this stuff, yeah? And this goes away. And this doesn't have that weird thing. And I recompile it again. And I rerun this. And I look at it again. Now I have only primary authors. So that's the one thing where you've got to either, that's the transformation in C#. In JavaScript, I could come up here and write or like a rename operation in MongoDB. But sometimes it's just easier to do it in C#, so you're certain the thing is exactly what the C# class looks like. Right? It's not always required. But those are your two options. You could do it as like basically an update script equivalent, but you write it in JavaScript instead of writing it in SQL, in the data modification language of SQL. Or you can do it with these transformations here. Right? Does that help?
Yeah, but I'm also thinking about some kind of continuous delivery process. We've got different versions of the code accessing the same database.
That actually is a problem. It's not a huge problem. So what I would do, like I'm telling you, the options for this stuff up here is crazy. So let me just show you, if I take this away for a minute. Let's not take that away for a minute. Let's take this one away for a minute. Why did I do it? All right, it's gonna run, it's gonna run. So see, it's crashing because it's now gonna throw away the primary authors. I can do something different, which might be what you guys need to do, is I can come over here and I say, you know, you've got this normal data, but just in case, I want you to have this thing called a BSON document here, which is like the native sort of C# level thing that holds the extra data. I'll call this additional data. And this will be BSON additional data. Is it BSON maybe missing data? Oh dear. BSON extra elements. I think it's extra elements. There you go. Now it's fine. You can't program against it in your current compiled version of your app, but the saving and loading will like just stash whatever it sees extra there. Does that make sense?
Could you achieve the same thing by inheritance? So you've got the version, fast version 2.
It's possible, but it would possibly break the older version of the app if a newer version saves into the database. So this is kind of your out to have multiple versions at the same time.
Yeah.
Okay. If you want to learn all about this kind of stuff, just do a little Google, Bing it with Google. So come over here and say MongoDB C# serialization, like that. And then you can see I've been here before, and there's just like tons of I've only shown you like half of the options. There's like way more stuff in here that you can control. Okay, so it's actually, the first time I saw it, I'm like, wow, they've actually really thought this through. There's a lot you can do there. Okay. All right. Good? Other questions? What do you guys think? Cool? Yes?
With Java, do you need to do any other special thing, like you said serialization?
You said with Java?
Yeah. So
There's...
do we need any separate settings?
Not really. There's a separate Java driver. There's two of them. One, there's an async Java driver and a non-async Java driver. So you may care about the async one, you may not. And it has its totally own API. Obviously, Link is not supported, so you do your own thing there, right? So the way in which you do it in the Java level is different, but it has the same effect. I honestly don't know what it looks like in the Java level. I don't look at that stuff very often. But I know that a lot of people do use it, and it's totally supported. There's like several people whose job is to like continually maintain the Java driver at MongoDB. Yeah. Oh, and by the way, speaking of at MongoDB, they, for those of you who are in London, which I'm guessing is a fair number of you, they actually have an office right here, and they have office hours, like free office hours. And you just go like, hey, I tried this with MongoDB and it sucks. Can you help me? And we'll help you for free. So there's like once a week or something you can do that. So there's a few places. They have places in Ireland, New York City, Silicon Valley, and then here. They may have somewhere in Asia, I'm not sure. But so there's not many places, but London is one of the places you can walk down the street, take your laptop, and go, hey, somebody help me with this. Okay? So that's worth looking into. All right. Other questions? Let me show you how we manage the indexes just on our develop.com stuff. Maybe show you some more realistic, like a real app sort of thing. Then I'll go and show you a few more slides, just to touch on a few other items. Okay, so, because I was talking about this yesterday, it's like right here. Awaken. All right, so this is an ASP.NET MVC website. And kick it off, just approve. There's no tricks up my sleeve. You can see develop.com, so hold on, I'll come back to that. But you come over here, and there's the app startup, and I've added a mongo.config to go along with the filter config, bundle config, all that stuff, right? And in here, it's got make sure that all of these indexes are there. And you asked about the profiler earlier. We just basically turned on profiling, clicked around for a long time, and said, okay, well, these are the slow ones. Let's add indexes for these things. Reset the profiling, clicked around some more until we found there was nothing showing up in the profiler. And we're like, all right, we're good. And the way it works is ensure index will basically say if the index doesn't exist, we'll make it. Otherwise, just forget it, right? So what we would do, we come over here. If you want a new version, I'm tempted to just push this button right now. Go to AWS, boom. It hits the AWS server, it restarts ASP.NET, it runs the Mongo config, which reevaluates the indexes, does that. You could even do transformation scripts if you really wanted, but I wouldn't bake that into the app, right? But so like 99.9% of the time, when we push out a new version, we don't even log into the server or the database. We just go, phoom, and anytime we need some new sort of configuration thing, we'll just throw it here, and it's kind of automatic, okay? Sometimes we log in there, but I couldn't push the button right now. It's actually behind a firewall, set of firewall rules on EC2 in Virginia. Okay? So it kicks all that stuff off and off it goes. Let's see if I can find something else here. Yeah, people are asking, what does it look like to write code here? So let's go over here. So here's our website. Come over here. Suppose I want to take something awesome like in the NoSQL space. Come over here, click on this. Let's take this class. Super awesome. Take it in New York. Click. Is this going to work? Yeah, okay. Because this is like the e-commerce bit. I wasn't sure if it required SSL to work. But see this, like, go register for this course with this ID? That is running that line of code right there, 16 and 17. And this is one of these nested objects. We've got our course, and within our course, we've got the events that are running all in one document. And so we just go to the course, get the one or missing one where the engagement is that ID that you were talking about, which is that event running in New York City here. Make sense? All right. This stuff is really fun, you guys. What else? Let me just go back to the slides and see what I can find. I don't really need my VPN right now or care about its maintenance stuff. Okay. Where's the other one gone? Let's just say carefully open with the old one that's not going to screw this up. There we go. All right, so let's kind of review how some of this stuff works, right? So the way it goes is you create a C# class. You can do aggregation and other interesting things. You can just have these classes, but they have to have a primary key so that normally something called ID. You can use attributes to erase it. Right? So here's an example. We want a book, you know, title, ISBN, author name, maybe a list of reviews, right? Remember, this is a like a nested embedded document. Here's what that looks like. Private stuff does not get serialized. You can put attributes on here and go, don't serialize this one. The common case where we use attributes is we've got, you know, we have those engagements, right? I showed you like that event running in New York City, and then we have our course. And we want to be able to, if somebody in our web app has a hold of the engagement, reach up to the course. But obviously the course holds the engagement. If we just leave those both in there, this will like crash when we try to save it. So it's a circular reference. So we just say bson ignore on the course within the engagement, and it's only like an in-memory navigation. All right, so we have this set up here, and when this gets saved, it just literally gets converted into JSON. Now, it's not stored on disk in JSON. It's stored in a totally different way. Not so different, but it's not stored as text. It's stored in something called bson, which we saw that bson document, which is just a binary version of JSON. So it's a lot easier for them to do queries on. Like, for example, if they had a number, like an integer, they would know that that's 4 bytes, right? So they can easily like just check that without having to parse the strings and things like that. Okay, so here's the code you would see if you'd have to write without using my little library. You have to create the client, go to the client, get the server. That's weird, but whatever. You go to the server, and then you get the database. The database does not have to exist. Right? It may or may not need to exist, but this will create one if it doesn't exist. Right? So no action that's taken here will actually do anything on the server yet. But it will, if you like save something, then that will sort of trigger a cascade of events that will create all those things. So here's basically what that class internally that I wrote looks like. It's on GitHub. You can play with it. And then you can derive from this thing, right, and it has your iQueryable properties. Makes it super easy to use, just like Entity Framework Code First does. It's basically exactly the same story. All right. Here's some more options for doing that. And here's that library. So here's a link to the library. All these slides will be put up at some point on the website. So that'll be cool. All right, and then if you go to query them, it's just either you have the context and you create as queryable on the Mongo collection, or if you use my little library, it does that deep down in the guts. You don't have to worry about it. You just write link against it, right? And we saw that you can, you know, use that to query syntax thing to turn that back into the underlying JSON API, or whatever you call it, the native API. So here are some things that you can ask. There are things you cannot ask, actually. You can upset it. But I can say, give me a single item here. I say where, I can say order by, select starts with. Now, one thing you need to be careful about being SQL Server people, for the most part, this is an assumption I'm making about you, is that MongoDB is case sensitive, whereas SQL Server is case insensitive. So capital A versus lowercase a means something really different here than it does there. But what's less obvious is when you create an index, I could create an index on title, and I could even do an indexed query on starts with, but I can't do a case insensitive query that is also indexed. That makes sense? That gets a little subtle, but so you might need to store like a lowercase version or like a keyword sort of broken down thing that you don't show to the users, but it's there so you can index it in a case insensitive way. You can do stuff like this, which is cool. Like here's a set of, these are the US West Coast states. And you say, give me all the books where the book, the West Coast states contains the author's state. Right? And that converts to like a cool little statement in MongoDB that's fast as it can be. You can also say where b.subcollection contains some item. Right? This is an array of strings or a list of strings, and so on. All right, so this is all wonderful. There are problems that you can have. Right? Some of this is standard length, and some of it is Mongo hard-learned lessons. All right. So here, this is a good thing to write. I could say, give me this as queryable, and go to the database and give me the thing named Alice. Right? You saw that converts to a thing which runs as a native query in Mongo that can be used in an index. It's super zippy. This, on the other hand, is bad. Guys, can you figure out what's wrong with that? Can you even see it?
You're going to get all of them.
It's going to get all of them. Why?
Because you need
Yes, IEnumerable, right? It's because this, even though this is returning iQueryable, this is an IEnumerable, and that like chops off a link and converts the link to objects. Right, so that's bad. However, this can be used for the power of good as well. So there are certain things that are not directly usable within MongoDB, but there are ways around this, sort of, in some ways, but group by and joins are not there. One of the new features they're looking to add to the server is actually joins and stuff like that. But right now, you can't really do cross-document stuff. In the query language, there's something else called the aggregation framework, which you can, but it's not the same thing. So some of these things don't work. Some of them that are really, you really want are select many. What if I just wanted to go get all the authors? I would say from B in books, select many b.authors, .distinct. And that would give me a distinct set of authors across all books, except select many is not supported. However, it's not that big of a problem. What you can do, if you try to write this, it'll give you an exception. So select many is not supported. I've gone back and forth with them on whether this is actually a thing that should not be supported. They think it means join. I tell them, no, it means look in a subdocument. Like, oh, well, maybe. Anyway, you could say as enumerable on the iQueryable, and then it would totally work because it's linked to objects. But if you had a billion records, it would be suboptimal in performance. So typically what I end up finding, me and my colleagues that work with this a lot write, is we write as much of a filter as we can on the iQueryable, and then we'll say as enumerable, and then we do the rest of the statement. So here we're not actually pulling back every book, we're only getting the books, maybe this is like a set of books, not just one, right? And this is possibly, right, Alice could have written many books, and then we say as enumerable and do the projection just down into the set of authors. Or what is that, set of reviews, yeah? It's not really much slower. I mean, you do pull back the whole book instead of just the author set, and you could actually pass things theoretically to do like sub-projections and so on, but this is kind of your way around a lot of the limitations. Let's see how much time do we have left here. Okay, a few minutes. I might show you something that's kind of amazing that will let you answer other interesting questions. It's probably worth doing if I had the database installed. So you end up writing kind of sometimes this duplicate query. Like here I'm going to do on the server, I'm going to get down to just the books with recent reviews, and then I'm going to do like a final projection on the client. But so what are we trying to do here? I want all the books. I want the reviews of the books. I really just want the reviews from today, right? But they're stuck within the book because my nested model I chose may or may not have been a good idea, but I chose it, so here we go. So what I want to do is do like basically a select many, but if I try to do that, it'll fail. So I'll just say pull all the books back that have at least one review for today. They may have other reviews that are old, but they have at least one review for today. Then I say on the server side, actually do like a select many to get down to just the books, just the reviews of today. Right? So you kind of got to be a little careful here. You got to repeat this stuff sometimes. All right, so saving these objects, you just new them up, fill out their data, call save. This says context.books.save. If you use my library, you don't say books, right? It's a slight variation on what's in the slides versus what's on GitHub. Okay, but you just save them. Similarly, if you get the book back from like a thing like this, you just make changes to it and you call save again and pass the book. The difference between the Unity framework and this is you don't say, it doesn't do the tracking within the data context, so you've got to pass it the object that's changed. You don't just say save changes and whatever happened, just save all that. Like it doesn't quite work that way. Turns out you won't miss it. Okay. Here, let me skip ahead a little bit. Yeah, all right. So let me show you some more stuff, and then we'll go back. So let's go back over here, and let's look at an example. Yes, I want to do that. So let me pull in an example from the class that I wrote for Developmentor, which is over in GitHub. Here, MongoDB, C#. Here, okay. I'm happy to give this to you. Let's just hope I have the database. Yes, there it is. Okay, so first of all, let's go install this. Now, normally I use there's two ways in which you back up and save these databases. So let's say cd desktop, make dir temp, cd temp. I'm going to throw this away. So what we're going to do is, suppose I want to back up the develop.com database. You guys remember how you do this in SQL Server? You open SQL Server Management Studio, you go find the database, you go to tasks, all tasks, back up something. There seem to be like 3 ways, only one of them really works. And then you attach a device, which is a file. Whatever. You attach the device, and you back up to that thing, right? You're like, oh man, this is so painful. So we say mongo dump --db is develop.com. So that's how you back up a MongoDB database. You might think, well, okay, that's kind of cool. So Michael, how do I restore a MongoDB database? Oh yeah, that's actually kind of hard. Mongo restore --db develop com -- replace with what is right here. Must be a dump of a single database. Oh, hold on. cd dump. And backslash. Oh, because I have drop. Mongo. No, that's right. MongoDB drop. I think maybe the order matters. It says drop. com / specify DB name. Am I not specifying a DB name? Yeah. Well, whatever. I'll figure it out. But that's basically what you type, and it's just like 5 seconds, and it's off it goes. I can say that I know what it is because Mongo. Somewhere in here, have my restore, I think. No, I don't. Yeah, I don't know what's wrong with it, but basically, it's just super easy, right? And it just imports and exports these JSON things. So I'm going to have to figure out what's going on because I want to use this. All right, so we'll say cd here. So I'll say Mongo, where are we? Yeah, Mongo restore. And backslash, don't know what to do the file. --db zip. There's something really bizarre going on here. I'm sorry. All right. Let me just show you the example. If you guys have questions, maybe I'll get it working. So we can go over here and let's look at this. This is really kind of amazing. Now this is a feature that they're thinking of adding to the driver. It's supposed to be in the new one that's released, but the new one's not released, so I can't tell you for sure how it's going to show up. But this was their prototype a little bit ago. So that zip data is all the zip codes, little postal areas in the United States, and then relating them to the cities that they're in, relating the cities to the states that they're in, and then the population of each zip code. So it's basically census data. So we come over here and look here. So this is like I said, a special version of the driver that would let you answer questions about the states. So it says, look at this. Tell me the states that have more than 5 million people living in it. Well, you've got to go to all the zip codes, look at their populations, and then put them back together in their states. So you can come over and say, group by, Z goes to the state, and then select out a new item, right, the key, and then you do like a computation on the sum over that subset, and then you do an order by, and then you do a where clause. And this all maps into a single statement that runs on the server. Nothing ever comes back to the client to do this. And there's a special aggregation framework that's kind of hard to use, to be honest. But let me see if I can just run it for you. It may or may not. There you go. So here's what the actual thing you would type into MongoDB would be. The pipeline is group by the state, then you do this aggregation $sum, and then you do this projection, and then you do a match, and then you do a sort, and you pop. Like, that is really nasty. Look at how beautiful this is in C#. Let's look at a more complicated one. It gets more complex as you go down. Here, look at this one. This is a thing of beauty. Show me the average city size by state. Okay, go there, group into this new object that links states and cities together. And of course, the set of the group are a bunch of zip codes for each of that composite key, basically. And then I'm going to go pull out these new items, and then I'm going to do an operation to get the sum. And then I'm going to, because now that tells me the sum of the size of the cities. And then I'm going to go put the size of the cities together by their state. And then I'm going to go do an average population based on those, and then you can do like a max and so on. And if you had to write that yourself, it would look, like this kind of stuff. All right, so these are like map reduce types of things. And they're working on putting that into Link as well, which will just be like, it'd be so nice. So I told you some things are not, the reason I showed you this is I told you some things are not supported in Link. They're not, but they're supported in this other alternative query thing that's like a big data engine inside MongoDB called the aggregation framework, right? For sure you can write this now, but they're trying to add it to the Link support for the new driver. Okay, it's not in the kernel. All right, let's see. Other questions, other comments?
Backup file you just produced.
Yes.
This is .json file. Is it literally?
It's literally JSON. Yeah. I'm really bugged that my Mongo restore is not doing its thing. I literally don't know what's Mongo restore -h. -d. And we'll see. Mongo restore -d zips /. Yeah. Not the zips. Yeah, I'm not sure what's going on there because I've done that like 100 times and it's always worked. So maybe they've changed it somehow. It would be strange. Oh well. Yeah, so it's just the records straight up. So it's not encrypted or anything, which is something you would want to keep in mind. Like, encrypt it yourself. Don't just, it's not like SQL Server where it has like a password to get to it, or possibly. Okay. Another thing that's pretty interesting that people ask about a lot, you guys have not yet asked about, but you'll get there, is I told you the largest thing that you can store in the database as a document is a 16 megabit document. This is for your own good, right? Because what if you say, I would like to find all the books that were published today, and they've got like super high-res PDFs that are like 100 megabytes each, and you get 50 books, right? That's a lot of data to be sucking back across the wire. And so they set some arbitrary, like kind of big limits on the size of the documents. And by the way, if you have 15 megabyte size documents, you're like, this is totally fine, it's under the limit. It's probably not fine. It's still probably not okay. This is like an absolute, don't go above this, we won't even let you type of thing. So what if you have like binary data you want to store? I could put a byte array right on the document. It would go in there just fine. But what if it were big? What do you do? So there's this other system called GridFS. And here, I'll just show you a little bit of it. And it looks like this. So what you do is you can take a file and you can say, go to GridFS and say, upload this file. And then the driver of the database, you don't ever know this or care about this, will break it into a ton of small little pieces, 256K pieces. store those in the database, and then store like a record that says, to get this file back, you go get these 27 little chunks of it. All right, and that lets you do things like random access into the document and all sorts of cool stuff. And then if you want it back, you just pull it back. So if we look at Mongo over here in RoboMongo, like if we look at our online training stuff, we've got this set here that has FS chunks and FS files. And if we go look at FS files, oh my gosh, maybe too much zoom. This will show you, let's look at it like this. So it'll show you the files, and you can see like these are the user profile pictures. We just made up this name, like there's no real directory structure, but we said so that it looks like there's directory structure, I can say give me the query of show me all the user pictures by finding all the documents that are, you know, file name starts with /user/picture/stop. Right, that'll show you all the records that would be like in that directory, if you will. And then it says, okay, the size of this bit, there should only be one chunk because of this, but you don't really know here. It just says, I broke it into the pieces that size, that's how big it is. And then down in here, there's this FS chunks piece, which if you look at it like this, you know, it says, okay, here's the ID of the actual chunk, here's the original file ID, here's the index of it, right? There's 0, 1, 2, 3, 4 to make up this file, and so on. So there's a really neat file system built into it, and if you guys are, you know, aware of or came to my like sharding talk, you could spread this out across like 100 servers with huge hard drives, and you can store like ridiculous amounts of stuff, basically in that file system, if you will. So a lot of people are doing that. A lot of people that are even using MongoDB still take their data and put it somewhere in like S3 or Azure Blob Storage or somewhere, and then just have a file name or link to it, right? Which is totally reasonable as well. But you could store it in this gridfs bit. Okay. We store small stuff in the gridfs piece and like really large stuff like video in S3. Because backing up the database, all of a sudden when it has a terabyte of video is less fun. Right. Okay, so there's 2 minutes left, but I think I'll just leave it for questions. Any parting thoughts?
You mentioned you can have a really big database you can query records really quickly.
Yeah.
How do you get the data in there? Are there tools for bulk loading?
Oh, so that's a great question. Are there tools for bulk loading? Yes, I believe there's a Mongo import thing that might take a CSV or something, but don't use it. The reason not because it's bad, because if you just take your data from SQL and just copy it into Mongo, you're losing the advantage of actually remodeling it in a better structure.
Yeah.
You know what I mean? Like you're just like, well, I still have the same problems over here as I had over there to some degree. And it might be that it's the same shape and you don't care and you can do that. So what I've done is I've gone to my SQL database, I've created an entity framework model of it, right? Easy enough. And I've created what I want it to be, my dream shape in the MongoDB classes. And then I wrote a function that said, for each thing in this table, assign these properties and call save. And it sounds kind of annoying. It's like a couple of hours for a decent project. It's not super onerous, but it's not automatic either. But what you gain is you get to restructure your data so that it's kind of native to this format, to this document format. And it takes advantage of it.
If I have a guy that sends me a massive JSON file, for example, once a week, like I do.
Okay.
You mentioned the backup thing. I'm thinking, can I just take that JSON file and restore it?
Very possibly. Very possibly. If you got to write code, let me show you something awesome. Over here. Say add. Oh, let's just put it at the bottom. Suppose that guy gives you some sort of JSON thing, and the JSON thing looks like whatever it is here, right? Let me just paste this really quick to see what it looks like. All right, now watch this. This is one of the cooler features of Visual Studio that very few people know. Let me put it up here actually so you can see. File, no, edit, paste, special, JSON as classes, boom. You seen that? It's awesome, right? And it'll do like nested object graph all the way down. It'll create like 3 or 4 classes if it needs to. So you can just take that format, do that, and go, okay, we'll start from here. Okay. So you may have to write like a quick little loop that parses it in, uses JSON.NET or something and assigns it. Or that might just tell you what your MongoDB object looks like. You know, rename it from root object. That's not a good name. but otherwise, you're on a good start, you know? Yeah. Okay, so it looks like it's 6 a.m. Perfect, it's time to stop. Apparently, that's where I came from. Makes me feel tired, but it's all good. You guys, thank you very much.